do I say there's got to be give on the quantum side? You see, unlike string theory, quantum theory has a huge amount of experimental support. See, some people complain about string theory and they say, well, okay, it's all very well, but it doesn't have any implications that we can measure experimentally. That's not really my objection to it, although that is an objection. My objection to strings is more that the higher dimensional idea, higher dimensional part of it doesn't really make sense in the physical world in which we live. When it comes to quantum theory, the issue was pointed out by Schrödinger a long time ago with his cat. And the idea is that you have an equation. This is the Schrödinger equation. Another way people refer to this is unitary evolution. And this is, in quantum mechanics, see, if you have the state of the world as described by quantum mechanics, the quantum state, then that evolves in time by a very definite equation. And this is the Schrödinger equation, or unitary evolution. And the trouble is, with that equation, as Schrödinger was clear to point out, that you could easily have an experiment in which a cat was dead and alive at the same time, and that's ridiculous. That was what he was more or less saying. So he was arguing that there needs to be something else which goes beyond the evolution that he'd put forward, the Schrödinger equation, and that is a change in the rules of quantum mechanics that we presently understand.
Do we know what that change is, or needs to be, or how to get around
each of us? Well, those of us who believe there should be a change don't necessarily agree about what the change should be. But the change, in my opinion, has to be when gravitational effects become significant. And this can be at a very tiny scale. You might think it was tiny. I mean, there is an experiment, for instance, which is being worked on by Dirk Bouwmeester and his colleagues in Leiden in the Netherlands and in Santa Barbara in the US. And they've been working on an experiment which puts a little tiny mirror. This mirror is about 1/10 of the thickness of a human hair in diameter. And this mirror would be into a superposition of two different locations. So we know in quantum mechanics that particles can be two places at once. It's a strange idea, but you have to believe that sort of thing if you explain things like the two-slit experiment and very many fundamental experiments in quantum mechanics. We know it happens with individual particles, that they can be two places at once, but we don't believe that it can happen to cats. So what about, where's the sort of dividing line between the two? Well, it's not quite a dividing line like that in my view, but it's something about how long these superpositions can last. So in this experiment by Bouwmeester and colleagues, you try to put this little mirror, as I say, 1/10 of the thickness of a human hair, into a superposition of two different locations, but they're not very far apart. They're only about the diameter of an atomic nucleus apart. But you hold it there for as long as you can, and the idea on the scheme that I'm trying to promote, you could only do this for a matter of, depending on details, a few seconds or a few minutes. So this is within the capabilities of current experimentation. It's not quite there yet, but I would expect that within the next decade they will have an answer to this question.
You also take on our idea of the multiverse, the many, unlimited number of universes that we may be living in. You think that's...
Well, one of the reasons people go to this kind of view comes from quantum mechanics. You see, if you think about the cat again, you see, the view would be, no, the cat has to be in this superposition of alive and dead. In my book, it's not alive and dead. I have the cat going into a room which has two doors, and the doors are, one of them and the other one are open. Only one is open, but it's a superposition of one being open or the other. And it's like a two-slit experiment, but with doors and cats. And the cat goes to some food inside the room, and you would think, well, a cat either goes through one door or goes through the other door. But quantum mechanics says it would be in a superposition of going through the two doors. And why is it you don't see this sort of thing? Well, the many worlds explanation is that, well, if somebody is watching the cat, and seeing it come through, well, whichever door. There would be one person seeing it come through at door A, and the same person, I should say, seeing it come through door B. But these two instances of the same person would then be thought of as inhabiting two separate worlds. So somehow the world is viewed as splitting. When I say the world, I mean that's the universe, would be viewed as splitting into two versions of it, one which would have the cat going through door A and the other which would have the cat going through door B. And so that's the way they understand this particular conundrum. And the thing is, that's the faith. People believe, oh no, you mustn't monkey with quantum mechanics. The rules that we understand have to be held to at all scales. And if you believe that, then yes, you've got to believe that the observer of the cat is somehow split in two and inhabits these two separate worlds simultaneously, and the experience of the observer somehow splits in two. And I've always found this as a reductio ad absurdum. And Schrödinger himself, as I say, pointing this out as a contradiction to experience. And not just Schrödinger, I should say, three others of the fundamental people who founded quantum mechanics: Einstein, de Broglie, and most surprisingly perhaps Dirac, who was the one who formulated the rules that all quantum mechanics people use. And he himself is on record, and I have a quote in my book where Dirac actually says this, that quantum mechanics is a provisional theory. And we've got to be prepared for a better theory to come along in which the world does not split in this way, because that's an absurd contradiction. But I mean, there are other people who believe it does split, and that's the view you're referring to, the many worlds interpretation of quantum mechanics.
Talking with Sir Roger Penrose, professor of math at Oxford, author of the new book, Fashion, Faith, and Fantasy in the New Physics of the Universe, on Science Friday from PRI Public Radio International. Do we need a new physics? Do we need to...
Well, I think we do, yes. Certainly, well, you see, people think about, if they believe that quantum mechanics, and new physics, of course, string theory isn't really an accepted theory of physics in the sense that it doesn't make predictions that can be measured currently. But quantum mechanics makes many such predictions.
And they're very accurate predictions, right?
Indeed, but none of them reach this sort of level of mass displacement. There are quantum experiments, which I think the current record is 143 kilometers. So it's not a question of distance. You can have quantum effects which straddle at least that distance.
That's the spooky action at a distance concept.
Yes, it is. That's exactly
how far apart we've observed it happen.
That's the current record of... There are also experiments where you observe stars, and then the distance between one edge of the star and the other, you get interference effects, which mean that the photons that come to you from those two extremities of the star are automatically entangled with each other. This is part of the framework of quantum mechanics.
Are you then saying that we need a way to explain the macro world and quantum, this tiny world of quantum mechanics with one overarching theory?
It's not as though you have a different theory for each. You have a theory which involves, in my view, it will have to involve Einstein's general relativity. So it's when the curvature of space-time starts to become significant. And I have a crazy-looking picture in my book which is showing if you move a rock into a superposition of two locations, then the space-time goes with it at first, and then there's a point at which one of them has to be chosen over the other, and that happens in a calculable time scale.
How do you get people to, if you say it's so hard, and one of the things you point out in your book is that because some of these issues are so ingrained in the scientific community, it's hard to get resources, money, to
That's absolutely true.
Investigate these other ideas. Who's going to get a graduate student to work on some of these new ideas?
You're dead right. It's very hard. I mean, I find this particular, not so much with the quantum mechanics, because I haven't been trying to do this experiment. Yeah. It's, as I say, people in the Netherlands and Santa Barbara, and there is money to do that experiment. So whether more would help them do it quicker, I have no idea. But the things where I notice the difficulty of getting funding is for the cosmological scheme. You see, the third topic is the fantasy one, which, as you say, I'm not so happy with inflation. And I think the inflation can't be right. Well, it's a very artificial theory, and I have a picture where you see all the different curves that people sort of draw by hand, more or less, in order this particle referred to as the inflaton, which nobody has really observed this or anything, but it's supposed to be what is responsible for the inflationary scheme.
So, Roger, I've run out of time. We could go on. Your book is 600 pages, something like that.
Read the book then, yes.
Sir Roger Penrose, Professor of Mathematics at Oxford, author of the new book. This will get you to think very carefully. Fashion, faith, and fantasy in the new physics of the universe. Thank you for taking time to be with us today.
Thank you very much.
I want to shout out to our New York listeners. Next Tuesday, Science Friday in Studio 360 are getting together at WNYC's The Green Space to celebrate the legacy of the Voyager Golden Record. It'll be a night of live music, cosmic conversation. More info at sciencefriday.com/golden record. Come on out to the Green Space. Plus, we've been on the air for 25 years, and I know I can't believe it either. We're going to have a big gala celebration on board the Intrepid Sea, Air, and Space Museum in New York. That's October 15th. If you want to come out and celebrate with us, it's going to be crazy. Go to sciencefriday.com/gala. Charles Berquist is our director, senior producer Christopher Intagliata, our producer Alexa Lim, Annie Minoff, Christy Taylor, Katie Heiler, Luke Rostigan, our video producer. Today we had engineering help from KQED, from Monty Carlos and Dan Bringer. Thanks also to Howard Gelman and all the folks at KQED for welcoming us to their home. And they're making space for us today during their peak pledge drive. So pitch in and support Science Friday and all the great shows you hear on all your local public radio stations today. Also, thanks to our production partners at the City University of New York. I'm Ira Plato in San Francisco.
Support for Science Friday comes from Organic Valley, farmer-owned organic co-op for over 25 years. Makers of Organic Fuel, a workout and recovery shake with 26 grams of protein, made from pasture-raised milk and 0 artificial ingredients. And from Lumosity, brain training with games to challenge memory, attention, and problem solving. From scientists working with university researchers to explore new areas in human cognition. Learn more at lumosity.com. Also from the Union of Concerned Scientists, putting rigorous, independent science to work to solve our planet's most pressing problems. On the web at ucsusa.org. Science Friday is produced by the Science Friday Initiative. Online at sciencefriday.com.
PRI, Public Radio International.
You're listening to the Ideas Network of Wisconsin Public Radio. The second hour of Science Friday is next. And join us tonight at 9 for the Dinner Party Download, the arts and leisure section of Public Radio. Tonight, it's a special all-TV episode featuring big talent from the small screen, including favorite TV theme songs. That's the Dinner Party Download, tonight at 9. And we invite you to tune in Monday afternoon during the 1 o'clock hour when Kathleen Dunn hosts the weekly show All Things Political. It's an in-depth look at all the top political stories of the week. That's All Things Political, Mondays at 1 with Kathleen Dunn, here on the Ideas Network.
We have listening options at Wisconsin Public Radio. You have your choice of the Ideas Network on 91.3 WHHI. There's WPR's full-time classical music service on 91.3 HD2, and the NPR News and Classical Music Network on 91.3 HD3, as well as 89.1 WSSW in Platteville. Learn more about our regional stations and how you can find them online at wpr.org/southwest. Wisconsin Public Radio for Southwest Wisconsin. This is Ideas 91.3 WHHI, Highland, Richland Center, and Prairie du Chien.